Hello class. We're going to do some more transformations on our functions. We've done vertical and horizontal shifts. Now we're going to be doing some reflections and some stretching and shrinking. Can you hear that noise behind me? I'm in my office, but my office has a dog door. And I have two dogs, and they keep going in and out, in and out. Where are they? Come here. Molly, Jenny. There they are. Come here. Come here. This is Jenny making a mess. She's crazy. Okay, get up. Can we see Molly? There's Molly. Okay, they're so cute. All right, go to bed. There they go. Go to bed. Stay there. Okay, maybe we can get some bath done now. We'll see. Get this camera back up. All right, more transformations on functions. That will be fun. All right, so we're going to look at f of x as our parent function, and g of x is going to be our child function. So let me get some ink on here. So we're going to be given f of x, then our g of x is going to be the opposite of f of x, and that becomes the graph of f of x reflected about the x-axis. What that means is that this x-axis is going to become the mirror. So this x-axis right there is going to be our mirror. That's what we're going to reflect about. So let's give ourselves some points for f of x. Our function is going to be the square root function. So we're going to have x and y. If you remember, we can't have any negative numbers because the square root of any negative number is not real. So we do not graph those. So let's go with 1, 0, 1, and 4 because those are perfect squares. The square root of 0 is 0, square root of 1 is 1, and the square root of 4 is 2. Let's graph that. All right, looks something like that. Now let's go to the graph of g of x. We're going to have x and y. And let's use those same points, negative 1, 0, 1, 4. The square root of negative 1 is not real, so we're not going to use that. And there they go again out the door. And the square root of 0 is 0. Well, the negative 0 is just 0. Square root of 1 is 1. The negative of that would be negative 1. And the square root of 4 is 2, and we're going to take the opposite of that, negative 2. So we're going to have points something like this. So you see how they reflect across that x-axis, if the x-axis is our mirror. So now we're going to move the negative sign, and that means that's going to change our reflection. We're going to go across the y-axis. So if we're going to start with our given is f of x, and this time g of x is going to equal f of negative x, and that's going to be the graph of f of x reflected about the y-axis. So that y-axis is going to be our mirror, so this line right here. And let's go ahead and give ourselves some points. We already graphed f of x is the square root of x, so let's use our real points on that one. That was 0, 1, and 4. And 0 is 0, 1 is 1, and the square root of 4 is 2. So that graph looks something like, oops, like that. Now let's go to the g of x. Oops, I want to do that in green. XY table. Well, if I start out with negative 1, the opposite of negative 1, oops, I'm sorry, let's start out with positive 1. Okay, let me just erase that. Okay. 1, the square root of, well, we put that in there, it becomes negative 1, and the square root of negative 1 is not real. So we're going to have to go to negative numbers. So let's use 0, negative 1, and negative 4. The square root of negative 0 is 0. The square root of the negative 1 or positive 1 is 1. And the square root of negative 4 is the square root of 4 or 2. So we're going to have a graph that looks like this. Maybe. There we go. So you can see how they reflect across the y-axis. Now we're going to get to some stretching and shrinking. We're going to do it vertically first. Next slide we'll go to the horizontal. But when we do vertical stretching or shrinking, that C is going to go on the outside. Oops. The outside of the f of x. So, and if C is greater than 1, it's going to be multiplying, we're going to stretch it. If it is between 0 and 1, we're going to shrink it. So let's work with a familiar graph that we know. Let's work with f of x is equal to x squared. And gets x and y points on there. We've got negative 2, negative 1, 0, 1, 2. And when you square those, you get 4, 1, 0, 1, and 4. Let's see if I can do a really pretty parabola here for us. All right, so that's our parent parabola. So let's give it a number that we're going to put in front of it. Let's look at g of x equaling 2 times x squared. So when we do those xy table, use those same points, we get negative 2. Well, negative 2 squared is 4, and double that is 8. Negative 1 squared is 1, and you double that and you get 2. 0 is still 0. 1 is 2, and then we have, oops, 2 and 8. All right, let's graph that one. Oh, let's see, negative 1, 2. Negative 2, 8. It's going to be something like this. Notice how it got thinner and taller with those points. And let's do one more. Let's do a shrink one. And so let's call that one h of x. And let's make it 1/2 of x squared. So we'll do an xy table for that. And let's do those same points, negative 2, negative 1, 0, 1, and 2. So that's going to be half of 4, so that's going to be 2. Half of 1 is 1/2. Half of 0 is still 0. And 1/2 and 2. So let's see if we can draw that graph. Yeah, it looks like that. It gets shallower and shorter, so we're shrinking it vertically. Hi. Okay, so we're going to do horizontal this time. Let's see. There we go. Horizontal stretching and shrinking. And when we are stretching and shrinking, it's going to feel different or backwards when we do anything horizontally. Because when we have C is greater than 1, we're actually going to be shrinking it. That means we're going to be pulling it in towards itself. And when it's less than 1, between 0 and 1, it's going to be stretched. We're going to be pulling it away from itself, making it wider. So let's go ahead and do the parent function here, f of x. We'll give ourselves some xy. So -2, -1, 0, 1, and 2, 4, 1, 0, 1, 4. So see if I can draw this. There's our parent function. Let's go ahead and get the first child function, g of x, and let's put g of x is equal to, and we'll put 2x in parentheses. That means the 2 is also being squared. And I am actually going to change my points here because I'm going to go with -1, -1/2, 0, 1/2, and 1. Because -1, when I multiply that, will be -2, and -2 squared is going to give me my 4. -1 times 2 is -1 squared is going to be 1. This still is 0. And then we have 1 and 4. So let's graph that one. -1 and 4. So you see how that went in there? And let's do an h of x. H. Okay, and one more. We're going to do h of x is equal to 1/2 of x squared. So let's get our xy table here. And I'm going to bring, where's my pen? There it is. I'm going to go -4, -2, 0, 2, and 4, so that I have, even numbers here. Half of -4 is -2, and squared is 4. Half of -2 is 1, and -1, and squared is 1. Half of 0 is 0, squared is 0. Half of 2 is 1, squared is 1. Half of 4, 2. And that squared is going to be 4. Oops, there we go. So let's graph that one. And it looks like that. This is actually up here a little more. And so that one is bringing it out wider.